Well, hello everybody. What I need to do with you today is I need to cover section 3.3 with you. It's a tough little section because there's a lot of theory in here. We're scratching the surface of what a derivative officially is. So there's a lot of algebra that's going to happen today. But things that you're going to see on the video real fast, there is a skill check. You might pause the video or come back to it at the end, but you might pause the video and see how you would do on that skill check, because we will quiz the next class, and then that skill check looks a lot like the quiz. So good luck there on that. Today I'm going to cover with you the average rate of change and instantaneous rate of change. And of course the assignment's going to be on Math Excel. So things that I know, guys, some things that's going to come your way. You're going to hear me say average rate of change a lot today. When we say average rate of change, that's the slope. That's the slope that you learned back in 7th or 8th grade. It's simply the change in y over the change in x. Of course, we're going to make it a little bit different because you won't be given ordered pairs. You're also going to hear today the word instantaneous rate of change. That's going to mean we're going to find the slope at a single point on a graph. And then we're going to call that the tangent line. I'm also going to cover with you today, we're going to talk a lot about the importance of that h that you've been seeing pop up a lot lately. So when we had to find f of x plus h, we'll talk about that role of h today. The h just represents the distance from your x value. So for instance, if I have an x value of 1 and the y value does not matter, and I have an x value of 3 and the y value doesn't matter right now, at this moment my h is simply 2. It's the difference from 1 to 3. But then what I'm going to do to you is I'm going to move this dot closer. And I might now tell you that my x value is 2.5. Well, my new h value is 1.5. So you're going to see that a little bit today on a program. So right there is the skill check if you wanted to pause the video. And then, of course, right after that is I've already got the answers down for you. And that'll be what your quiz will look like next time. Answers, and I'll keep on going. Now, if you would, you're going to need your class examples. So pull those out. I may not do every problem on this because I don't want my video to get super long. But here goes on this one. It says a free-falling object is dropped from a height of 100 feet and air resistance is neglected. The height h of the object at any time t can be given by the formula negative 16t squared plus 100. You might recognize from your Algebra 2 FST days, that's Newton's law. The table below shows the height of the object at various times. So at time 0 was at 100 feet. At time 1 second later was at 84, 1.5 seconds, 64. So you kind of see how the chart works. Now here goes. It says find the average rate of change, the average velocity, over the following intervals from 0 to 1. Well, guys, here's what we're really doing. At time 0, I was 100 feet in the air. 1 second later, it was still 84 feet off the ground. We're just going to go get that slope. 100 minus 84 is 16. 0 minus 1 is negative 1. So I know we're at negative 16 feet per second. Now, guys, I won't always write as ordered pairs. You'll see it really like this. You'll see f of 1 minus f of 0 over 1 minus 0. That means the y value at 1 minus the y value when x is 0 over the 1 minus 0. So, for instance, on B here, two ways to do this. I could think about the ordered pair 1, 84 and the ordered pair 2, 36. I just pulled that information from the table. Now I'm going to go 36 minus 84 over 2 minus 1. And I'm going to get negative 48 feet per second. Not written as an ordered pair, it would just look like this. F of 2, the y value when x is 2, minus f of 1, the y value when x is 1, all over 2 minus 1. Okay? And then, guys, just the same thing here. If you do this, that would be f of 2 minus f of 1.5 over 2 minus 1.5. So it looks like f of 2 is 36. F of 1.5 is 64. Over 2 minus 1.5 is 0.5. Looks like that's going to be 28 divided by a half, so negative 56 feet per second. And I'm not going to worry about that one. So guys, so far, average rate of change is just slope. So remember that so far. Here's your next example. Find the average rate of change on the interval from 1 to 3 of the function f of x equal x cubed plus 3x plus 10. Okay? Now, what we're doing here, guys, is I've got some value when x is 1. I've got another value when x is 3. What we're finding is the slope of what we call a secant line. Secant line, remember, hits your graph at more than one place, in this case twice. So, two ways to think about this. I could think of the ordered pair 1 comma something and 3 comma something. If I plug 1 into the equation, I'm going to get 14. If I plug 3 into the equation, I'm going to get 46. My slope, my average rate of change, 46 minus 14 over 3 minus 1. Looks like that's going to be 32 halves, so it looks like 16. Like I said, I'm going to get away from this here pretty quick, guys. Mathematically, it also looks like this. F of 3 minus f of 1 over 3 minus 1. My y value when I plug in 3 minus my x value when I plug in 1 divided by 3 minus 1. So really from here on out, I'm going to really start writing it that way. Here comes our next one. Cigarette consumption in the United States has been declining. That's a good thing. Since reaching a peak in 1960. Per capita consumption since 1980 can be modeled by that formula that I give you there, where T is the number of years since 1980. Make sure you catch that. The number of years since 1980. Find the average rate of change from 1985 to 2005. So instead of 1985, I'm using a value of 5. For 2005, that would be 25 years after. So it's going to look like this. I need the y value when I plug in 25 minus the y value when I plug in an x value of 5 over, well, it'll be 20, but 25 minus 5. That's going to be about 1,807.2 minus 3323.3 all over 20. Run that through our calculator. We're going to get about 17 cigarettes per year. That's the decline between 1985 and 2005. So guys, average rate of change, slope. Change in y over change in x. So whenever you hear the word average, just regular old slope. Now, come to your next one. This one's going to be a little bit different. It says we'd like to find the instantaneous rate of change at 2. So I'm going to give you the graph of y equal f of x equal 0.5x squared. I would like to find the instantaneous rate of change right there. Well, guys, we've never done anything like this. For us to do average rate of change, for us to do slope, you have always been given 2 points. So I'm going to give you 2 points. To do this, I'm going to ask you to find the average rate of change on the interval x equal 2 to x equal 4. So from x equal 2 to x equal 4, we're going to find that. So I'm going to go f of 4 minus f of 2 over 4 minus 2. Looks like f of 4 is going to be 8. F of 2 is 2 squared is 4 times a half is 2 over 2. So it looks like this slope is 3. Now, while I'm here, I'm going to start plugging this h value. Right now that h value is 2 because it's 2 units from 2 to 4. So what I've done to you so far, The slope from here to here is 3. That's all I've done to you so far. Now, what I'd like to do on the next line is I'm going to say, well, that's close. That's close. But let's get closer. I'm trying to find the slope right there. So instead of using an x value of 4, let's bring it on down to 3. And we're going to do that same work. We're going to go f of 3 minus f of 2 over 3 minus 2. So I'm going to get 4.5 minus 2 over 1. So now my slope is 2.5. While I'm here again, my h value happens to be 1. So now I'm going to ask myself, can I even get more accurate? I'm trying to find the slope right here. Right now I'm that far away. So of course the answer is yes. What I'm going to ask you to do on the next one is I'm going to use an x value of 2 still. That's where we're trying to find our slope. But now I'm going to ask you to bring our dot in closer. So instead of being at 4 or 3, now I'm going to ask you to make it at 2.5. So we're going to go f of 2.5 minus f of 2 over 2.5 minus 2. I'm going to get 3.125 minus 2 over 0.5. So I'm going to get a new slope of 2.25. So I'm estimating at this moment that the slope right here is about 2.25. Once again, my h value in this case is 0.5. So notice what I'm trying to do to the h values, guys. First it was 2, then it was 1, now it's 0.5. Now I'm going to ask you to bring the dot in a little bit closer. I'm going to ask your h value to be 0.3. So on my next slide, we'll do that. So I'm going to pick the pace up on this one. If I go f of 2.3 minus f of 2, and I divide that by 0.3, we're going to get a slope of 2.15. And if I do it one more time, guys, if I do f of 2.1 minus f of 2 over 2.1 minus 2, I'm going to get 2.05. So peek at what I've done to my h values. 2, 1, 0.5, 0.3, 0.1. Notice I'm trying to get those to be small. The closer I can put my two dots together, the more accurate my slope is going to be. So since we've been studying limits, see if this makes sense a little bit. I would like to find the limit as h gets smaller and smaller and smaller, so h approaches 0. That's going to be key here within the next minute or so. So hang with me on this next little part. I'm going to give you a graph. Pretend you don't know what the equation is. This graph could be any graph in the whole wide world. It just happens to be the parabola I used because I just snipped it. But here's what I'd like to do. I would like to give you any x value in the whole wide world. But instead of calling it x, I'm going to call it h. You'll see why. So here's where I would like to find the slope at. Right now, that point has a value of a, comma, f of a. That's the ordered pair. If you knew the equation and knew the x value, you could plug that in and get the ordered pair just like we did before. Now, here's that h value. Up here's another dot. Instead of calling it b and f of b, I'm going to call it a plus h. Remember, guys, h represents the distance between your x points. To get the y value for that, I would have to plug whatever you have in. So here's what I've done to you so far. A represents any x value. Any x value you want to assign to it. F of a is a corresponding y value. Now, there's a distance between our x values. The h represents that. Now, we're going to find the slope of the secant line between those 2 points. So it's going to look like this for a second. I'm going to have f of, I'll write up here, I'll have f of a plus h, whatever that y value is, minus f of h over a plus h minus a. That y value minus this y value over this x value minus this x value. Now, while I'm here, a plus h minus a, looks like the a's are going to cancel out, so let's get rid of those. There's the slope of the secant line. Now, keep in mind what I did to you on that other slide. I want this h value to get smaller and smaller and smaller. I want that h value to be so small that these dots look like they're on top of each other. To do that, I'm going to find the limit as h approaches 0. Now guys, here's a formula for instantaneous rate of change. On the next slide, I have that written nicer for you. What we're doing is finding the slope of the tangent line at that point. So let me come to my next slide for a second. You'll need to write this formula down on your sheet there. So we got the limit as h approaches 0 of f of a plus h minus f of a all over h. So guys, don't do this to yours. If the limit as h approaches 0 is not in there, this is the slope of the secant line. Remember, the secant line touches the graph in two places. To turn it into the slope of the tangent line, you need to play with the h and make it really small. That's what that does. So a, good old word, help me and capitalized it. Little a represents the value of x that we're trying to find the instantaneous rate of change. Also, this represents the slope of the tangent line. We are going to use this formula over and over and over. Okay? The only thing that's going to change now is we're going to assign a value there and there. So, hang with me on this. It's really not hard now, but it's a little bit of algebra in there. So, come over to your next example. It says, suppose that a car is stopped at a traffic light. When the light turns green, the car begins to move along a straight road. Assume that the distance traveled can be modeled by the function s of t equal 3t squared, where t is the time in seconds and s of t is the distance in feet. Think about what's happening. The car's taking off. At first it's probably kind of slow, but you're building up speed. You're building up speed. Okay? We're trying to figure out at that exact instance how fast are they going to be going. And it looks like my units are going to be feet per second. So here's what it's going to look like. We're going to start with this formula. The limit as h approaches 0 of f of a plus h minus f of a all over h. Now, we're going to sub in a number for a. So now it's going to look like this. The limit as h approaches 0, we would like to find the instantaneous rate of change, the exact speed, at 10 seconds. So we are going to find f of 10 plus h minus f of 10 all over h. Here's our main setup. Every one of our problems is going to start like this. We're going to put a value there and there. Now here comes the algebra of it. This is going to become the limit as h approaches 0. Now, come up into your original equation. Wherever you see a t, we're going to substitute that with 10 plus h. So it's going to start looking like this. I've got 3 times 10 plus h quantity squared minus f of 10, the value I get when I plug in 10 into the original function, all over h. Okay. And of course, if you would plug in 0 right now, you're going to get 300 minus 300. You're going to get 0 over 0, which means there's a limit. We just got to go get it. So guys, I won't skip any steps on this video. I've got the limit as h approaches 0. I've got 3. I'm going to FOIL out 10 plus h, and I'm going to get 100 plus 20h plus h squared minus, I'm going to go ahead and plug in 10 into our function. 10 squared is 100 times 3 is 300 all over h. Now guys, it's just algebra from here. The limit as h approaches 0, I'm going to distribute. I've got 300 plus 60h plus 3h squared minus 300 all over h. I'm going to squeeze it in right up here now. I now have the limit as h approaches 0. Notice that my 300s cancel out of there. Here's going to be a rule. Not really a rule, but it should happen. If one of your terms does not contain an h, it should cancel out. So if it doesn't, and it doesn't cancel out, you messed up somewhere in your algebra. Now, the 300s cancel out, so I'm left with 60h plus 3h squared all over h. I can now take out a h out of each term. That's powerful because at this moment, I'm getting rid of that 0 over 0. So now I'm with 60 plus 3h. I can finally plug in 0 for h. So my limit, my derivative, my slope of the tangent line, the instantaneous rate of change, is 60 feet per second. That's going to be our steps on all of these. So that's what we got so far. Come over to your next one if you would. It says the distance in feet of an object from a starting point by s of t equal 2t squared minus 5t plus 40, where t is time in seconds. Now, be careful on these. Find the average velocity. Average velocity is the same thing as average rate of change. That's what we started the lesson with. This problem's asking you to go get the slope. So you have two ways. You could do the ordered pairs, or I want to find the average velocity from 2 to 4. You could go 2, plug in 2, add to 4. And if you plug in those, it looks like you'll get 52 for the 4 and 38 for the 2. Now, I won't write it that way. I'm going to write it this way. I'm going to say I'm going to have f of 4 minus f of 2 over 4 minus 2. Average velocity, plain old slope. Then I'm going to have 52 minus 38 over 2. So the average rate of change looks like going to be 7 feet per second. 7 feet per second. Now, here comes a tougher one then. Find the instantaneous velocity at 4 seconds. So now we're going back to this formula. The limit as h approaches 0 of f of a plus h minus f of a all over h. In this case, a equals 4. So it's going to look like this. The limit of f of 4 plus h minus f of 4 all over h, and that's the limit as h approaches 0. So here comes the math portion of it. We're going to go wherever we see a variable, toss it, and plug in a plus h. So it's going to look like this. I'm going to have a limit as h approaches 0 of 2 times 4 plus h quantity squared minus 5 times 4 plus h plus 40. So I've taken care of f of 4 plus h. Now, when you run 4 through the equation, just grab your calculator and run it through. Don't try to write all of those, because I found over my 100 years of teaching, students mess up a sign and then it doesn't cancel out. If I plug 4 into this equation up here, you're going to get 52. So I've got minus 52. And all of this is going to be over h. I'll do my next line in a different color. So the limit as h approaches 0. Now it's all algebra. So I'm going to FOIL this out and distribute it 2. So 4 squared is 16, distributed 2, I'm going to have 32, plus 4 times h is 4h, doubled is 8, doubled again is 16. So I got 16h plus 2h squared minus 20 minus 5h plus 40 minus 52. All of this is over h. Now, if it does not contain an h, guys, it should cancel out. So I've got 32 plus 40 is 72. I've got negative 52 and negative 20, which is negative 72. So that canceled out. Now I'm here. The limit as h approaches 0. You can combine like terms at this time, or you could wait. I spy 16h and negative 5h. So I've got 11h plus 2h squared all over h. I can finally remove that 0 over 0. So I'm going to take out an h out of everything. So I got 11 plus 2h. I'm going to plug in 0 for h, and I get my instantaneous rate of change to be 11, in this case, feet per second. So that's our steps when it says instantaneous rate of change. Here comes my next one. It says, a company determines that the cost in dollars to manufacture X cases of the famous DVD, Mathematicians Caught in Embarrassing Moments, I made that up myself, is given by C of X equal 100 plus 15x minus x squared, and it works on the interval from 0 to 7 we found. So what we'd like to do is this. To find the marginal cost, we're trying to find the instantaneous rate of change at 5. At 5. Okay, there it is. So I had the table. So it says, find the average rate of change. So guys, remember, when you hear average rate of change, that's going to be your f of 5, or in this case, c of 5. So let me write that properly. C of 5 minus c of 1 over 5 minus 1. If I plug 5 into the equation, I've got 150. If I plug 1 into the equation, I've got 114 over 4. Run that through your calculator, we're going to get $9 a case. We're going to get $9 a case. Now my next one though, we would like to find the instantaneous rate of change at the 5th case. Guys, what that means is this. How much is it costing us to produce that 5th case? Notice that if I look at my chart, notice at first my cost is kind of high, of course, but we're going to start going down a little bit. We're going to start going down a little bit. So here comes the instantaneous rate of change. In this case, my A value is 5. So we're trying to find this, the limit as h approaches 0 of f of 5 plus h minus f of 5 all over h. Now, I'm going to go plug that in. So wherever I see variable x, I'm going to plug in 5 plus h. So now it's going to look like this. The limit as h approaches 0 of 100 plus 15 times 5 plus h minus 5 plus h squared. So that took care of that. And then I still got to minus away f of 5. So if we plug 5 into here, we're going to get minus 150 all over h. And then from there, guys, it's algebra. So it's going to look like this. The limit as h approaches 0. I might switch colors here so they won't blend. I'm going to have 100 plus 75 plus 15h minus 25, because I'm pulling this out now, minus 10h, that times that doubled, minus h squared, minus 150, all over h. Whew, there's a lot there. Now, once again, guys, if it does not have an h in it, it should cancel out. So there's 175. Notice here's negative 175. If I simplify this now, I've got 15h minus 10h, so I've got 5h minus h squared all over h. Factor out of 5, I'm going to be, or factor out of h, I'm going to be at 5 minus h. I can finally now let h go to 0, so my instantaneous rate of change, my instantaneous cost was $5. So it looks like I got one more for you. If you understand it pretty well, you're welcome to not do the rest of them. I'll go ahead and fly through this last one. Find the instantaneous rate of change. Oh, I'm going to go ahead and skip that one, guys. It's kind of an easier one if I remember right. Let's go to this guy. The other one's just a bunch of algebra. So at time 0, unless it had a cubic in it. Nah, it didn't. At time 0, a diver jumps from a diving board that's 32 feet high. Because the diver's initial velocity is 16 feet per second, his position function is given by h of t equal negative 16t squared plus 16t plus 32, where t is the time in seconds. When does the diver hit the water? Okay. Well, to do this one, guys, the height when he hits the water is 0. So I'm going to set 0 equal to 16t squared plus 16t plus 32. And then I'm going to factor that. I'm going to graph that. Just looking at the graph, it looks like 2, but let's make sure. I'm going to divide both sides by negative 16. That way I've got t squared minus t minus 2 equals 0. That's nice because it factors into t minus 2 and t plus 1. So it looks like he's going to hit the water at 2 seconds. Looks like he's going to hit the water at 2 seconds. I'm going to throw away the negative 1 because that would be this part over here. Now, of course, you knew this part's coming. What's the diver's velocity at impact? Velocity, instantaneous rate of change. Same thing. So we're shooting after this one now. We're going to find the limit as h approaches 0. In this case, my a value is 2. So I got f of 2 plus h minus f of 2 all over h. Okay. Now, here comes all the algebra of it. So I'm going to plug in 2 plus h wherever I see a t up here. So I've got the limit as h approaches 0 of negative 16 times 2 plus h squared plus 16 times 2 plus h plus 32. I also need to plug in 2. F of 2 is, in this case, 0. So I don't have anything there. All over h. Well, guys, what I'm going to do, hopefully this won't confuse you, but I am going to FOIL out 2 plus h and get 4 plus 4h plus h squared, and I'm going to distribute a negative 16. So 2 squared was 4, times negative 16 is going to be negative 64. 2 times h is 2h, doubled is 4, times 16, oh, let me get over there, times negative 16 is negative 64h, minus 16h squared. And then I got plus 32. Plus 16h plus 32. So I distributed right there and got my 32 and 16h, and I got that plus 32. All over h as I'm running out of room again. I've now got the limit as h approaches 0. And then guys, remember, if it doesn't have an h, it should cancel out. If it doesn't, we did something wrong. Negative 64, 32 and 32 make positive 64, so good news there. I've got negative 64h minus 16h squared plus 16h. So it looks like I'm going to have 48, negative 48h minus 16h squared all over 2. All over h, sorry about that. Factor out a h and get negative 48 minus 16h. Let h approach 0, so it looks like I've got negative 48 feet per second. For the instantaneous rate of change, the velocity when he hits the water. So guys, that's a lesson. Not a hard lesson to be truthful, but a ton of algebra. So hang in there on that. That's the limit method of a derivative is what that is. Now, we are on Math Excel on the assignment, so I should have changed this one. So assignment-wise, we're going to be in Math Excel. I went to this slide, though, because I wanted to remind you that we'll quiz next time. So we'll quiz next time. So good luck on the assignment, guys.